Okay, so 720p video without flashing lights. Okay. So I got through the process. Hopefully this should be 720p video. It should be 30 frames per second instead of 15. Alright. It seems like the S's sound a little bit weird on this camera. Like I have like a... Okay. So here again is the camcorder. You can see me that I'm wearing this thing here. I was thinking I'm going to get a hat, so I'm probably going to purchase that. You can see here this is the setup. I've now fixed the time. That's supposed to be 12:22, almost 12:23, right? p.m. and it is Wednesday, January 4th, 2016. So I pretty much got my extra couch and stuff put away over there. And I kind of have to move my head a little bit slowly with this thing on. Let me just go ahead and turn this on just a little bit. Start recording. Alright, so now I have the camcorder on. It's recording with this on. I'll probably put this on a hat instead. So, alright. So, I did manage to find the elastic bands. And this is where I'll have additional stuff. This is a lens cleaner, though I usually use alcohol wipes for that. Anyway, so I've got a new temperature measuring kit. This will be able to measure 4 temperatures. This camera's pretty bad, so I'm going to go ahead and see if this light makes any difference. If I hold this up to the light, do I see in any way, shape, or form, do I see this clearly? That should be visible. Alright. So I found this on Amazon. It can measure 4 temperatures. So that's that. And while I might have multi-hour recording on the camcorder, I won't have it on this this camera here. This precisely, what's the name of it? See here, it's the SQ8 Full HD 1080p Mini DV camera, and this is the operation and instruction manual. A little bit it's not very clear. Anyway, so here I've got all right, S.H.O drive logo, and there is the oscilloscope here. And I've got, let me see if this is any clear on our system. Let's see here. Alright. Now obviously you can't hear me on the camcorder very well when I'm over there, unless I speak very loudly. There is it. We got this oscilloscope. And I'm going to get rid of this purple trace here, which is just in memory. So that's under data. So let's go change to data. Use these arrows. There's the minus sign. Notice this little triangle on the very right corner there. Purple or violet, fuchsia, or whatever triangle. And we're going to flip it over around that triangle. Okay, now it's input plus that, data, data minus input minus data, minus input, off. Okay, so basically, we've got that taken care of, and we're going to do this again later. So basically, I've got a cursor V1 and V2, so there's blinking V1 that's on top, and then V2 is on the bottom. There's V2. Let me just go ahead and see this. I'm going to go ahead and close circuit here. Now, I've got right here, got 5 volts separating the top and bottom triangles here. Cursor V2 is too far down, so let's move that up. And cursor V1 is pretty much at the right spot. Okay. So that's a 4 volt difference between the top and the bottom. And then the trace here, threshold, that's the threshold. So if I move the threshold below this thing, it won't be able to detect it. Now it doesn't know where it goes or where it triggers. Now if I put it there, then it can see that. And here we have a frequency that's trying to measure at around 1,000 cycles a second. And so let's say, for example, we want to change our frequency here. We see this menu allows us to change that. See at 10 kilohertz, it's kind of wobbly already. And then 20 kilohertz, it's really not having a... But it works at lower frequencies, and that's good enough for the S.H.O drive. I don't expect any weird high frequency hum or whatever. It's not going to be a high frequency device. Okay, here it's having a little bit of problem, like at this setting, but let's say, for example, I change the time scale. What if I change the time scale? Okay, so let's just change the time base. Okay, already we have no longer an issue. Now let's say, for example, we want to go the other way. Let's say we want to work with 20, let's see, for example, okay, megahertz, that's too much. But at 50 kilohertz, it kind of can handle this. Okay, maybe change the time base some more. 1 microsecond, okay. So let's go ahead and increase the frequency. Now it really can't handle it at 0.2 megahertz or 200 kilohertz. It's not really handling it, and kind of just, this is just, yeah, it's not really, I mean, it just doesn't have that many samples per wave, so it's not even going to help that much. Okay, anyway. So now at this frequency, it can no longer hold. So let's go ahead and change the time base again. Now it works. So it's 2 seconds. Okay. That's 10 hertz, 50, 100, 200 hertz. Okay, now I can't really handle that at all. Let's see here. Time base. Now, okay, now we can start seeing stuff again at 0.1 of a millisecond. Okay. Okay, 0.2 milliseconds. And we have at 1 kilohertz, so now what would that this so 1 kilohertz. This span over here, let's go ahead and change our X stuff, cursor T1, flashing over there. Is that even focused? Okay. Let me move it over here to the right, and then T2. Okay, it's focused. Okay, alright. So there's T2, 1 millisecond duration there. If I were to change this, reducing it, if I put it where that red line is, then I have something like that. Something like that. Okay, so that was about that 1 millisecond, half a millisecond. Now this is a millisecond. Okay. All right. So anyway, that was enough of that. Let me go ahead and turn this off. But we can just go ahead and probably just save a picture. Let's go ahead and save a picture. Save it as a bitmap, probably. Let's go ahead and let's save it as 5. Save CSV, make it 5. Load data. Okay, so let's just go ahead and zoom out a little bit here. Okay. What else? Wow. There's the microphone wasn't even on. Now I just turned on the microphone. Okay. So yeah, I hope you heard that part. Okay. So I'm gonna have to do some kind of overlay on this video. Yeah, so let me just go ahead and, or how about synchronize the sound a little bit. Should be able to. Alright, that should make it easy to synchronize the sound. Okay, so let me just go ahead and zoom out of here. Alright, so now the camera is recording with audio. I think remember to turn on that microphone. Okay. So again, that was the oscilloscope. I just kind of reviewed it with absolutely having no proper audio whatsoever. But basically I was going through the menus. This was the Y range. I actually didn't go over that. The cursor. Let's go ahead and zoom in here. So the cursor, this is the cursors for V1, and then V2 is down there. For example, moving that line, that's V2. Similarly for X1 and X2, I was adjusting the frequency on this meter to, for example, changing the frequency to 200 hertz, 5 kilohertz, you get the drift. You see here, I go here, then the Y, the distance between the top and bottom Y is 4 volts. And then for the X values, the difference here is 1 millisecond, which is in line with the frequency input, which is 1 kilohertz. If I double that frequency and I try to say adjust the, let's say I adjust X or the cursor T2 and I move it to the left to match this waveform. Let's say I move that one over there, and then I move T2 over to the right. Then kind of have half millisecond there, or 496 microseconds, which is about half a millisecond, at a frequency that measures at 2 kilohertz, 2,000 cycles a second. If I change my inputs, change my input frequency, then this one tries to measure it, although it's not exact. So that's like 504 hertz or 488 or something. Then I make input frequency of 200. This is actually measuring like 198 or 214. So this doesn't produce a very accurate signal. Okay. So yeah, again, I was going through this stuff down here. Basically, let me go ahead and turn this off. And so, again, 2016 S.H.O drive file build plan. This hasn't really changed. I still have some of these printouts for the magnetic rotor construction. Let me go ahead and zoom out of here. Magnet rotor construction, and chemistry products. Okay. Yada. So this is a magnet rivet construction. This is for the magnets that will be on the shaft. Okay. We've got some long magnets here. If you can see that. Okay. And then over here we've got some short magnets here. And that goes on this second layer and the fourth layer. In between the second and the fourth layer, I have thicker magnets. Okay. So the difference between the thicker magnets and the thinner magnets is the thinner magnets are 1/4 inch thick, and the thicker magnets are 1/2 inch thick. So basically, the way this will work, this will be an 1/8 inch thick. I think it's 1/8 inch. Okay, so I know that, no, that's a 1/4 inch, I believe. Anyway, so this is this is a 1/4 inch thick. That's the 1/4 inch thick ones on the leftmost stack. This one here should be 1/8 inch thick. No, 1/2 inch thick stuff. That's from the middle stack of magnets, and then the top and bottoms are from that stack over there on the most right. Okay, so yeah, here's my wipes that I'll be using to wipe things. There's the magnet rotors stack. I'm gonna have to change this. I'm gonna take these out. Yeah. Okay. What else is new? Okay. So this here, if you can see it, is the anyway, this is the trail camera. As you can see, we got the table in view. You can kind of see underneath. So there, all right. And this camera, the camcorder on the tripod over here. Okay, anyway, that's kind of weird. Let's go ahead and take care of that. So, just gotta make it harder to fake things. We got a light here, it's a 100-watt LED light. And you can see the reflection over there. So, yeah, okay. And what else is new? There's a S.H.O drive logo. And downloads, S.H.O motor project. You barely read stuff. Okay. What else is new? Go to, what are we doing here? Other, that's not it. S.H.O.wiki. No. Maybe it is other. So I just put this on the Facebook website, magnetic fields of the permanent magnet. Yeah, okay. That is not supposed to be. There's S.H.O squares. No. Let's go ahead and go to S.H.O wiki. That's stupid. Where are you at? There we go. Okay, so there it is. See how good this camera really is. That's not that good. Anyway, there it is. Magnetic fields of the permanent magnet look like that. Magnetic fields of the S.H.O coils looks like that. You can barely see it. Trace some sampling points like this. Over there. Okay. Just wanted to show that. Okay. So anyway, yeah.
So I really have nothing else to say about this right now. I'm probably going to get a hat or something to put this clip on, or maybe I just have to remember how I put this on because it was falling out earlier when I was recording, and this thing also doesn't have that much duration in it. It only has up to like 32 gigabytes of memory, and it can only record for a small amount of time. Built-in lithium battery can support 100 minutes of camera shooting. Okay. So when I go ahead and test the S.H.O drive and I start, trying to see if it runs or not, I want to make sure that I have the first-person view of the S.H.O drive working, so that way we don't get any issues with, people saying it's fake or something, because it's gonna be really hard to fake with, my head moving in the slide here. That camera's recording at 60 frames a second, 180p. I've got this on, I've got this camera on, I've got a reflection on the sphere. My head blocks this mirror here. This is actually a mirror. You can't see that from the camcorder very well, but that is a mirror, a modified mirror. And also, when I go on the S.H.O drive, it's going to be on a crate, and I'll be able to carry on the crate while it's running. I've also got things like this here basket. I could probably fit in this basket somehow to carry it around, maybe like do some tricks with it, kind of show it's not fake. What else? There's also space outside. I could go ahead and test the S.H.O drive outside if it's to kind of prove like we're not faking this. There's a place I can just suspend this outside. It looks sunny outside. It's gonna be sunny for the next couple of days. Got like 2 or 3 weeks I'm not with my job right now because of issues with the holiday season. They were shut down over the holidays, and then when they came back online, I was kind of like, I'm going to be reassigned to a different position, so I wouldn't be working until next week. But strangely enough, during this winter time here in the Northwest, got several days, clear days and clear nights, and so this is really probably the best time at this time of year to demonstrate the S.H.O drive. Okay, so yeah, I would like to thank you for your time, and have a wonderful day. And let's go ahead and get that. So 12:51 p.m. Wednesday, January 4th. Okay.
potential energy source of the future is as small as a coffee cup, but the power is reportedly explosive. That's
Anyway. All right, have a great day.